This video series focuses on the basics of statistics reported in the literature, with the goal of providing the necessary background to read and understand research results. This first video addresses what statistics is and how it's used, and provides an overview of hypothesis testing. By now, you have probably read hundreds, if not thousands, of journal articles. But how closely have you looked at what the authors say about the statistical analyses they used? And how thoroughly have you read through the results section? Every field of study has its own terminology. Knowing the meaning of a few key statistical terms and concepts will help you to understand the statistics reported in a research article. So let's look at these terms. Here's an example from a paper on plaque accumulation around orthodontic appliances. The authors indicate the statistical test used, as well as the level of significance for these tests. The significance level, sometimes referred to as alpha, is a commonly used term. In the results section, the authors indicate whether the results were statistically significant. P, or the p-value, is the measure used to determine statistical significance. Here are the terms we've seen. The statistical tests themselves are beyond the scope of this series, but I'll discuss the rest of these concepts. I'll also talk about confidence intervals. In the remainder of this video, I will explain what statistics is and how it's used, and I'll provide the basic ideas behind hypothesis testing. Statistics is a branch of mathematics based on probability. In the context of research, it can be thought of as a tool to help researchers make decisions in the face of uncertainty by basing these decisions on probability. Researchers study phenomena by gathering data from samples drawn from a population of interest, and then generalizing from those samples back to the population. They don't study the entire population because it's usually not feasible, due to time, cost, or just practical limitations. If you were studying patients with periodontal disease, the population is all individuals with periodontal disease. But you cannot collect data from everyone in the world with periodontal disease. And even if you could, you would still miss those whose periodontal disease is yet to be diagnosed. Those who might develop periodontal disease in the future would also be excluded. Instead of trying to collect data from an entire population, researchers choose a sample that represents, as closely as possible, the population of interest, and then make generalizations or inferences to the entire population based on these sample results. Let's look at research from the world of orthodontics. The photo on the left shows a self-ligating bracket system in which arch wires are ligated or held into the bracket slot using steel ligatures built into the bracket. On the right is a system that uses elastic polymer bands to secure the arch wires to the bracket. These researchers are studying oral hygiene outcomes for different orthodontic systems. If elastic bands present a barrier to good oral hygiene, then perhaps there will be a difference in plaque buildup between the elastic module and self-ligating systems. Their research question is whether the elastic module system results in higher plaque scores than the self-ligating system. But to test this research question, they have to turn it into a hypothesis, a precise, testable proposition about an area of study, and a critical component of the scientific method, the systematic search for knowledge through observation. They are studying two groups of orthodontic patients, those who receive the elastic module system and those who receive the self-ligating bracket system. The outcome of interest is plaque accumulation, which the researchers define as scores on the modified plaque index. This index produces an average or mean score using facial and lingual surfaces of all non-restored teeth except third molars. The researchers expect greater plaque accumulation for the elastic module system, so the research hypothesis is that this system will produce higher mean plaque index scores than the self-ligating brackets. To test this hypothesis, they set up another statement called the null hypothesis, a statement of no difference or no effect. If there's no difference between the two systems, then the mean plaque index will be the same. Because the researchers expect mean plaque scores to be higher for the elastic module group, the null hypothesis also includes any mean difference that is less than 0. The null and research hypotheses are mutually exclusive and together account for all possible outcomes of the study. In this case, the elastic module system either does or does not result in higher mean plaque index scores. Rejection of the null hypothesis means support for the research hypothesis. Accepting or failing to reject the null hypothesis means lack of support for the research hypothesis. Researchers are usually not happy with this outcome because they are generally looking for support for their research hypothesis. Here's how hypothesis testing works. The researchers focus on the null hypothesis and create a distribution of all the possible sample results that can occur when the null hypothesis is true. When certain assumptions have been met, this is what such a distribution would look like. This shows all the possible values for the sample mean difference in plaque scores, elastic module minus self-ligating brackets, when there's no real difference in the population between the two systems. The x-axis represents sample mean differences, and the y-axis represents frequency or proportion. 0 is at the middle of this distribution, but there's a wide range of possible values to either side of the 0 point. If the null hypothesis is true, the researchers would expect their sample results to be around 0. But because of sampling variability, they might get results that favor self-ligating brackets, or results that favor elastic modules, even when there is no real difference between the two. The researchers hope to reject the null hypothesis, thereby establishing support for their research hypothesis. The further away the sample results are from 0 in the positive direction, the more likely they are to reject the null hypothesis, because such results are much less likely to occur when the null hypothesis is true. They're only looking in the upper half of the distribution because the research hypothesis states that the elastic module system results in higher mean plaque scores. To summarize, the first two steps in hypothesis testing are to state the research and null hypotheses and then create a model of the null hypothesis. The researchers then collect their data and conduct statistical tests, which will be used to make a decision about their results. The next video in this series focuses on the significance level.